Sorry about that. Forgot I was muted. Okay, so welcome to R. R is a programming language made for statistics. So everything in here is built for data analytics. So in this workshop, we're going to be going through some of the more basic parts of R. We're not going to be able to cover absolutely everything, but hopefully this will be enough for you to get your feet on the ground and get the basics of your project started. So if you want to download RStudio and go for yourself, the download is pretty simple. You honestly just search up RStudio on Google and then click on the first link, and then there's a download button right there. So it's pretty simple and easy to use. So if you want to follow along and fire it up, then that's okay. If you don't, then this is also going to be there. So don't worry if you don't have it open right now. You can always look at this later. So in order to use R, you need to first install the data sets you're using, because you can't do data analytics if you have no data. So the syntax for installing packages is like this. So install.packages and then the name of the package. So the two packages we have right here, this Gapminder package is basically data on a whole bunch of statistics like GDP per capita, population, life expectancy, that kind of thing. And COVID-19 analytics is basically about, we're all stuck at home because of COVID-19. So it's just a data set on cases, how it on various regions around the world. So to install, the syntax is like this: install.packages. To load it, you use the library and then the name of the package. And then this step may not apply depending on your data set, so you'll have to check your documentation. But if you want to be lazy and then not have to keep calling it, you can use data and then the name of the data set. So let's just run this. Running. There we go. It's loading stuff. Loading. The bigger the data set, the longer it might take. And then, so it's not the snappiest thing in the world, but it gets the job done. So as you can see, it's already successfully loaded. So summary gives you a brief overview of the data. So let's just call summary on the Gapminder data set. And as you can see, we get a whole bunch of countries, GDP per capita, a 5-number summary, a 5-number summary for years, life expectancies, populations, a whole bunch of stuff that's basically a top-line overview of the data. And then the syntax of the summary function may depend on the specific library you're using. So be sure to check the syntax of it, just to make sure that there's not some special function that the people who made your data set made that does it for you. So this is for the COVID-19 analytics data set. And it's reading from the repository. And then we get this, wonderful plot that's still being loaded. But as you can see, you can do a lot of stuff with R. So for example, this plot is confirmed cases. And as you can see, the US has the biggest share, and then it gives you a whole bunch of nice other plots. So again, just be sure to check the documentation of whatever you're using, just to be sure that they didn't secretly make something like this and you're not flailing around and trying to do something that you don't really have to do. So the $ is used to select a specific value from your data. Again, I've said this a lot, but I'm going to say it again, and I'm going to keep saying it. Check your documentation because it depends on the structure of how they structured that data set. And if it's if they did some really weird stuff, then this may not work. So just be sure to read the documentation. So for example, so this would be taking the mean life expectancy from the Gapminder dataset. That's what this line means. So if we run it, we get the mean life expectancy is 59.47444 years. The way you assign variables in R is a little bit weird if you compared to like Python or C++ or Java or whatever other languages you've learned. So the way you use it is this little arrow thing. So if I do this, X arrow thingy equals mean of the Gapminder life expectancies, then X will become that thing. So X is going to become 59.47444, And again, look at your syntax because your data set might, the creators of your data set might have added some features that allow you to do different things, but it may not work the way you think it does. So this will assign a time series to all data. So if we just run that, reading the data, loading. Again, depending on the data sets you're using, it may or may not do this, just because some data sets are live and some are static. So again, if you see like weird loading things and like data being read from random repositories, don't worry, that's normal because some things are being constantly updated in real time. So if you're feeling lazy, then you can use the attach functions to make a data set your default. So then if we want to say attach Gapminder, we can do median pop, so the median population in the Gapminder data set. And notice that we didn't need to use the $sign here. So we can just call it, and R is going to be like, okay, which data set is the default? Okay, we're going to use that one, and then it's going to do things. So if we run it like this, we see the median population is some number that I don't want to read. So R has a few built-in data visualization functions. So hist makes a histogram, boxplot makes a boxplot, fairly basic stuff. So if we run it, we get a histogram of life expectancies, a boxplot of life expectancies. And then we can also get the histogram of life expectancies, all well and good. If your data are skewed, then you can also do log plots. And the way you do that is just putting log in brackets around whatever you want to do a log plot of. So for example, if we do a histogram of the population versus the histogram of the log of the population, they look kind of different. So as you can see, this is a lot nicer. It has a much more normal distribution kind of shape than this thing over here, which is all bendy, wendy, and curvy, and that's not fun. And then like this is not something you want to look at. So then if you have something like this, then it makes your life a lot easier, and it gives you a better sense of what you're doing, basically. So use the tilde character to create dependent and independent variables. So if we want to do a box plot of life expectancies by continent, you use this little character. So if we just run it, you'll see that we get a whole bunch of life expectancies segregated by continent. So in this case, continent is your independent variable and life expectancies is your dependent variable. So just be sure to get it the right way around in case otherwise your data is going to be flipped on the X and Y axis. So, just be sure that if it's the right way around, and if it's not, then just switch them. It's not that difficult. Scatter plots are created using the plot function. So here we're creating a plot of GDP life expectancy with the log of GDP per capita as the independent variable. So if we run this, you see we get this really, I wouldn't call it nice looking, but interesting looking graph. And you can see there's some sort of linear relationship there. So this might be if you're, say, using, if you're trying to create a whole bunch of, if you're trying to do data analytics on that Gapminder data set, something like this would be something you'd want to look further into. So that's just like the basic functionality of R. If you want to take full advantage of it for like data visualizations and making things pop and look cool and not be like, sad black and white images like this, then you'll have to install a few libraries that aren't part of like the vanilla stock version of R. The ones we're going into today are Dipler and ggplot, but again, check the documentation of the dataset because oftentimes the people who make them are really nice and better at programming than you or I am. And they made a whole bunch of cool stuff that makes cool graphs, and it does things that you would probably not be able to do on your own in a week. So for example, if we do this funky thing, which frankly I don't understand, but was in the documentation for the data set, it's reading the data, reading more data, still reading even more data. And then we get this really cool plot that shows the number of cases, confirmed, recovered, deaths, and active over time. And I believe this is also a log plot of it, but they didn't label the axis. So, but as you can see, like, this is like a really nice looking graph that you could use in your final report or presentation or what have you. And like, this would probably take you a lot of time to make. So be sure you're checking what you're doing just to be sure that, like, you don't miss out on really good looking stuff like this because you didn't read the documentation. So here's how to use a Dipler. So installing it is install.packages, and then library is loading it in. So let's just do that. Oh, yeah, okay. You may or may not get this error depending on like when you're using, depending on what exactly you're doing. But the reason this error popped up is because I already ran through this when I was practicing. So this package is already downloaded and installed and ready. So then it's like, hey, you're up trying to load something that's already loaded. So if you see this pop up, don't worry. It just means that you're loading something that you're already using. So you shouldn't run into any problems with that. So this is called the pipe operator. So it basically acts as and then. So this whole thing looks scary, but it's really just a whole bunch of and then statements. So let's go through it. So it's Gapminder, and then we're selecting countries and life expectancies. And then we're filtering by country, Canada, and then or country, South Africa. This little vertical line thingy works like or. And then we're grouping it by country, and then we're summarizing, and then this syntax creates a table. So the dependent column is assigned to the country's average life expectancies. That might not make sense when I say it, but when it shows up, it should make a little more sense. So summarize basically just makes a table. So as you can see, we have an average life expectancy for Canada of 74.9 years, and for South Africa, 53.99 years. So this is basically the syntax to create a table. It feels a little weird, but like, you'll get used to it after time. And then if you're lucky, you may not have to do this if the people who made your data set are nice and they did a whole bunch of fancy stuff on the back end, and then you don't have to do this. So if you're unlucky, you'll have to do a whole bunch of weird stuff with percentages and pipe operators. But don't worry, it's not, once you get the hang of it, it's not all that bad. So, we just learned how to make a data table, and that's all well and good. But in order to make your report, you kind of need to do statistical analysis on the data that you have. So here's how to do a t-test or a test for significance for a difference of means within your data. So as we can see from this table, there's a substantial difference in the life expectancies of Canadians, 74 years, compared to the life expectancies of South Africans, so basically 54 years. So this could just be like random chance. I don't know, maybe everyone in South Africa just got hit by lightning one day and died. But it's probably not that. So we need to figure out if it's just chance or is there something deeper going on there. So what we're doing here is we're taking the data from before, so this stuff right here, and then we're putting it in this variable called data frame 1. So what we're doing is taking Gapminder and then selecting country and life expectancies, and then filtering by countries, Canada and South Africa. So let's just run that. And it's run. And then all you need to do a t-test is just t.test. So data equals data frame 1. That's just saying, hey, look over here to find the data. And then telling it to basically test life expectancy by country. So we take our previous data frame and tell the computer to do a t-test comparing the life expectancies of Canada and South Africa. So if we run that, we get this nice little thing, Welch 2 sample t-test, data life expectancy by country, all your t, your degrees of freedom, p-value. It gives you your alternative hypothesis as well. It gives you a confidence interval, which is really nice if you want to look into the broader statistics of it. And then it gives you, these values are from back up here, so it gives you the average life expectancies as well. So based on the p-value we got, which is, this is 8.95 times 10 to the minus 10, which is like really small, we can say that there's a statistically significant difference in the life expectancies of Canadians and South Africans. So basically, it's just a whole bunch of stuff to do statistics with. But if you want to make really fancy looking graphs, then ggplot is the way to do it. So first we have to load it, and I'm going to get an error message because I already have it. So using it, so Gapminder, and then we're filtering by GDP per capita less than 50,000. And then this here is I'm going to explain it after I make the graph, but it looks really complicated, but I'll explain it after, and it's not really that complicated. So as you can see, we get this really nice looking graph. So let's go up here and explain it. So this AES just means like we're going to pretty it up. So we assign the log of GDP per capita to the x-axis, and you can see that's true down here. And then the y-axis is life expectancy. You can see that over here. We color it by continent. That's what the COL stands for, so coloring by continent. And then size equals population. So you can assign color and size, and there's a couple other things you can assign as well. I'm not going to go into them, otherwise this would take like 50 years. But you can assign a lot of things to make your data much more clear, and so you can use it on your graphs and explain it better. And as you can see, for example, Africa is this reddish pinkish color, and you can see it's mostly clustered over here with some points over there. And the Americas are these greenish brown colored dots. Europe's these blue colored dots. So it does a lot of stuff to make your data clear for communication, and it also just helps you understand it better. And this point at the end just tells it, hey, these things, assign them to points. And then you can see, it gives you a legend as well. So ggplot is definitely the way to go if you want to make really pretty graphs for your presentation. I highly recommend you explore on your own, however, because if I went through every single little thing, you'd probably forget. And it's a lot better to do experimentation because like, even though I've been programming in R for a while, there's stuff even I don't know. So there's a lot of potential for great visualization. It's just a matter of like looking through the libraries that you have, and maybe even if you want to do some more research onto other libraries that I may not know about, then like please go ahead and do so, because like, we're just here to teach you. And if you can teach us in return, that's always good. So another useful thing we can do in R is linear regressions, which are basically like, long story short and very oversimplified, trend lines. So the way you do that in R is just LM, linear model, life expectancy explained by GDP per capita. And then if we run that, you get, so call formula equals life expectancy by GDP per capita. And you get these funky variables. It doesn't really explain them that well, but if you plot this line, then it should give you like how much GDP per capita explain like life expectancy. So it shows that there's a correlation, but like that's kind of, it's pretty basic. It doesn't really tell you much. So if you want to do some more advanced linear modeling, you can take the summary of the thing we just did. So this gives more in-depth stats as p-values, which are kind of important, and residuals, which are basically like errors like in prediction. So it gives you a 5-number summary for your residuals. And it also gives you a whole bunch of like t-values, standard errors, a whole bunch of stuff that I don't really want to go into because, I don't want to take up 50 years. So it gives you a lot of stuff, but like this is important. This is important. Like R squared is something you're going to want to look at. So yeah, like it's a really simple thing, just summary on your linear model, and it gives you all the in-depth, all the stats you could really ever want. And then you can also do it with multi-variable models. So linear model life expectancy by GDP per capita and population. So if we do that, then it gives you 2 explanatory variables. And that's basically it. I hope this is enough for you to get started in R. If you have any questions, please ask them in like the Slido. And then if you don't have anything for now, but it comes up later, please ask in the Slack, because we're here to help you and not like some weird overlords that are here to like say, do statistics and then go away and then make you be sad and on your own. So yeah, that's basically it. You can find this RStudio document in the GitHub. I recommend running it cell by cell, because if you run the whole thing at once, then it's going to go like super fast. And then it's going to be stuff everywhere and it's going to be really messy. So yeah, run it cell by cell. Okay. Okay, questions. Oh, I have a couple saying you can't find ggplot. The name is actually ggplot2, I assume, because they made like a second version of it and the first version doesn't exist anymore, but everyone just calls it ggplot because reasons. So the name of the package is ggplot2. Hopefully that's helpful for anyone who can't find it. Should we copy and paste the whole code from GitHub? Or so yeah, do it section by section. Just because otherwise it's going to be a mess and you're going to see stuff everywhere. But if you want to run the whole thing at once, then go ahead. Okay, if the graphs aren't coming up for you in RStudio, I haven't run into that problem before. Maybe try restarting your R, or maybe try updating to a newer version of RStudio. I'm not sure why you'd run into that problem. If you're having trouble downloading R or RStudio, then I'm not entirely sure how to help with that, to be honest. There's probably an FAQ on the RStudio website if you're having trouble downloading. Oh, yeah, someone just said in the meeting chat, if your window is too small, then your graphs won't show up. So try expanding the window where it does all the code stuff. Is there an editor function in RStudio? Like, yeah. RStudio is pretty intuitive. The way you run cells in RStudio, I didn't go over this, but it's just Shift Control Enter on whatever line you're on. So then, like, it's easy, makes common sense. Like, yeah. Black and white graph showed up, but you weren't able to get it in color. Unless you're using ggplot, then I don't think R itself supports color. Like as far as I'm aware, there's not a way to do things in just R that gets you stuff in color, but there might be, and I may not know about it, but ggplot is generally the way to go. Recap what plus basically just means and. How to visualize linear regressions with R. So I didn't go into this, but this may depend on the data set you're using, like because like as you saw in the workshop, like the COVID-19 analytics had some built-in stuff. If you want to do it with, like, say, the Gapminder thing, sorry, I'm having a bit of a brain fart right now. Yeah, sorry, I'm having a bit of trouble remembering how to do that. But I will put it in the Slack later for you. How do you check the documentation? So when you go and like Google and search for your data sets in your research, then there should be a documentation page for your data set. So for example, the COVID-19 analytics data set has an entire like page on like how to use it. So most good data sets will have documentation like written up on how to use them. And if you can't find the documentation, then like, you can try working with it, but it gets a lot harder to use your data set if you don't know how the data structure is. Yeah, downloading RStudio, unable to locate. Yeah, if you're having, I'm not sure why you would have trouble downloading RStudio. Yeah, if you're having trouble with that, I don't know what that really means. What file format should the packages be? To be honest, I'm not entirely sure what file format packages are, because the way I work in R usually is just just call install on it, and then it downloads, and then it goes somewhere on my computer, and I'm not entirely sure where that somewhere is. How do you find data sets online? So honestly, the easiest way to find data sets is to Google whatever you're interested in. Like do your background research, find a topic that you're interested in, and then put our data set after it and then see what pops up. You may get unlucky with like what you find, but But yeah, can you make a grouped bar graph from a CSV file? I actually haven't worked with CSV files in R all that much. I'm pretty sure you can in Python, but I'm not sure about R, to be perfectly honest. Where does the dataset COVID-19 analytics come from? Okay, so I can show you. So I'm going to put that in the meeting chat real quick. So that link that is in the meeting chat, if you click on that, you'll see a massive page. And then on that page is the documentation for the COVID-19 analytics dataset. So like it has basically every function call you could possibly ask for. And then play around with it if you'd like. Yeah, someone says use tidyverse if you want to use CSV files. So that's how you do that. I'm trying to play code and it says life expectancy is not found. Are you sure you ran every cell? Because if you don't run every cell, then it may not find, it may not realize you're trying to run the right data set. So make sure it's installed properly first. Package installation process is taking forever. How can I make it install faster? Yeah, no, installing packages, no matter what programming languages you use, it just takes forever. Like it's just something you have to deal with, unfortunately. Especially if your data set is like big as the COVID-19 analytics data set is, then you have to read a lot of data from the internet. So it just takes a while. Especially if your computer isn't, super powerful, then, it'll take a while. There's not really much you can do. Try closing anything running in the background, maybe. If you have Chrome running, then Chrome eats RAM so maybe try closing Chrome or any other programs that are running on your computer. Can you import Excel files into RStudio? Yeah, I believe you can convert Excel files into CSV, and then CSV you can use. Someone said tidyverse. I'm not sure how that works, but you can try looking that up and seeing if that works. Group bar graph, format of packages. Yeah, CSV file. Oh yeah, someone said install the package OpenXLS. So again, just search around. If you want to do something that I didn't show in the tutorial, then Google is your friend, because there are people that are a lot smarter than I am that have probably done this already. So yeah, working with CSV files. People have suggested packages in the chat. So like if you want, look at those. There's probably others out there that I don't know about. Do you think RStudio Cloud will be sufficient for this project? So from what I know about RStudio Cloud, they're currently in a beta. So then, you might not get all the functionality, but like, honestly, in my personal opinion, and this is my opinion, I'm not saying you should follow it, but I just like having things on my own computer. If your computer is having trouble running it, or is just too slow, or you don't have enough space or what have you, I'm sure RStudio Cloud will work. But in my personal opinion, I like having stuff run on my computer. So that's my opinion. But as far as I'm aware, RStudio Cloud works fairly well. How do we input data into R from other sources? Yeah, so if you're having trouble, then importing data, look it up. Your data types might be different, especially if you're using CSVs, which I don't really use all that often, to be honest. On line 17, I get this error. Error packager namespace load failed for COVID-19 analytics. Yeah, if you're getting loading or like package error failures, make sure it installs properly. Like if you run those first few lines and then if you run those first few lines and it gives you an error, then something's gone wrong. And like you're gonna have to do debugging on your own because like every bug is different and every error is different. And you know, we can't troubleshoot everyone's problems for like 50 years. Confused as to which data sets so the way the big data challenge works is that you're generally speaking, you go and find your own data sets on what you're interested in. We can help you find data sets, but like you're gonna have to find something that you're interested in and like that relates to your project, because like, you know, not everyone can do a project on COVID-19, otherwise it will get a bit boring. Are there any step-by-step directions on how to write the code for CSV XLS? To be perfectly honest, I usually use packages already made in RStudio, but like if you check out, people are saying in the chat that tidyverse is really good, but just search for libraries and then they should have the documentation on how to do that. So just follow the tutorials you find online. And I think that's everything for questions I see on here. So yeah, thank you for showing up. Thank you for asking questions.
Hey, Dhananjay. Sorry for interrupting, but I just wanted to like mention, like follow up on like 2 questions that I missed. Would it be okay if I could?
Oh yeah, go ahead.
Thanks. So yeah, sorry I missed like a few questions. So yeah, you can like access the slides in the recorded workshop on the Google Drive. I think like we can like share the link on the chat. If you guys want, we can like share the slides on the Google Drive, and also like regarding like other like data analysis like methods and stuff, like if you have any more questions, like you can like always email me and Dhananjay regarding like what was it like the ANOVA and chi-squared stuff. You can like email me if you have any questions. Sorry I didn't address that in the presentation, but yeah. Yeah.
Okay, so I guess that's everything. So thanks everyone for joining our workshop. So we will have another workshop at 3:30 Eastern Standard Time. So in half an hour for introduction to Python. So hopefully we can see you there.
See you, everyone.
Bye.